Imagine yourself in the shoes of a cartographer from the distant past. Your mission is not merely to sketch a map of your village, but to create a chart of an entire region. You get into a boat and begin your journey down a winding river. The reedy banks give way to dense forest, and uncertainty awaits you around every bend. You carefully sketch the visible shoreline and mark the streams that flow into the river. But what lies beyond that wall of trees, a mile from the water? What valley stretches behind the hill on the horizon? Your view is blocked by obstacles, and you can only guess what lies hidden beyond them. After traveling 10 miles, you try to transfer your sketches onto a single sheet of paper. You immediately face an unsolvable problem. You don't know the true curves of the river, as you've never seen it in its entirety. You can't correctly place its tributaries, let alone map the features hidden from your sight. Any attempt to create an accurate map from ground or water level is doomed to failure. It isn't just difficult, it's physically impossible. The only thing you can create is a primitive sketch, based more on rumors and guesswork than on real data. But physical obstacles are just the tip of the iceberg. Imagine you need to map lands controlled by 3 different warring tribes. You are in the territory of Tribe A. At great risk, you can study and sketch their lands. But how do you get to the lands of Tribe B, who consider you an enemy? A single step across the border would be your last. And to reach the lands of Tribe C, who don't share a border with your people, you would inevitably have to cross the hostile territory of Tribe B. It's a closed loop. Information about neighboring lands becomes inaccessible. Each nation can only map its own territory, but the larger picture of the world remains a complete mystery. Creating a single, objective map in a world torn by constant conflict is an impossible task. And even if we imagine the unbelievable, that some brilliant master could see through mountains and become invisible to his enemies, a third unbreakable wall emerges. This is the complete chaos of measurement systems. Every city, every region had its own units. Feet, inches, miles, cubits, leagues. Their values changed from one place to another. How could you possibly create a unified map if the data collected in different parts of the world was simply incompatible? Imagine you need to chart all rivers longer than 300 miles. But how do you measure that distance when Asia, Africa, and America have their own unique units of length, incomprehensible to a European? Agreeing on a single standard was impossible. It would be like trying to assemble a complex machine using parts made from different blueprints with no shared system of tolerances. The result would not be a map, but an absurd collage of disconnected, unrelated fragments. Thus, every path for an ancient explorer-cartographer led to a dead end. A limited view, hostile neighbors, and the lack of a unified system of measurement made the creation of an accurate geographic map fundamentally impossible. And yet, archives and museums hold astonishingly accurate maps of the world, created long before the age of satellites and airplanes. If it was impossible to create them by traveling on land or water, then only one option remains: an almost fantastical method for its time. One that solves all of these problems at once. When all paths on the ground lead to a dead end, and the horizon always hides the truth behind forests and mountains, there is only one direction left to go: up. The only way to see the true outlines of the continents, to trace the actual course of great rivers, and to peer into the forbidden territories of your enemies, is to rise above them. To gain that objective, all-seeing perspective, which is unavailable to any traveler moving across the planet's surface. Today, this method is known to everyone. Aerial survey. From a height, insurmountable obstacles vanish, hostile borders become mere lines on the ground, and the chaos of different measurements can be unified into a single, scalable system. The solution seems simple, and is the only one that makes sense. any accurate map could only have been created from the air. And it's right here, in this simple and logical conclusion, that we hit a brick wall of historical paradox. Official history tells us loud and clear that the first controlled flight of a heavier-than-air craft took place in 1903. The famous flight of the Wright brothers was, in reality, a short hop. Their plane stayed in the air for less than a minute and traveled only a few hundred feet. It was a monumental achievement that opened the skies to humanity, but it had nothing to do with map-making. The first decades of aviation were a heroic saga of survival in the air. Planes were fragile, their engines were unreliable, and every flight was a risky venture. Pilots of that era weren't concerned with cartographic surveys. Their main goal was simply to reach their destination, and not all of them succeeded. It took years for airplanes to be able to travel even a few hundred miles without refueling and repairs. It wasn't until 1937 that the legendary non-stop flight of Valery Chkalov from Moscow to Vancouver took place. A journey of over 5,000 miles across the frozen Arctic. Now that was an event that could make one seriously consider the possibility of systematic aerial surveys of large territories. But that was the 1930s. The paradox is that incredibly accurate maps of the world, with astonishingly correct outlines of continents and islands, already existed long before then. They were sitting in archives, printed in atlases, and hanging on the walls of geography classrooms. How is this possible? How could maps exist that required a technology that would only appear half a century later? This isn't just a minor historical discrepancy. It's a fundamental contradiction that calls the entire official timeline of technological progress into question. We have artifacts, the maps, that, according to our own understanding of history, simply could not have been created in the time they are dated. This glaring gap between the existence of the maps and the supposed absence of the technology to create them forces us to shift our focus. If the answer doesn't lie in the age of airplanes, perhaps we should look earlier. This paradox forces us to take a closer look at the 19th century, an age of steam, electricity, and great discoveries. An age that, as it turns out, is full of unsolvable mysteries and holds the key to the secret origin of maps whose accuracy rivals our own. So we are faced with an undeniable fact. In the 19th century, there were geographic maps whose accuracy cannot be explained by the official history of technology. They exist. You can see them and touch them. Museums and libraries hold thousands of these witnesses, atlases, textbooks, and photographs of classrooms with world maps on the walls, showing outlines remarkably familiar to us. To deny their existence is pointless. This means we must find an explanation, no matter how incredible it may seem. This is the epicenter of the mystery, a historical anomaly that forces us to choose between two staggering, almost fantastical theories. The first theory suggests that the maps were indeed created in the 19th century. This assumption forces us to completely reconsider our knowledge of that era. It implies that alongside steam engines and the first electric light bulbs, there existed some unknown, perhaps hidden or lost, aviation technology, advanced enough to carry out a global cartographic project. These wouldn't have to be airplanes as we know them, but they would have to be aircraft capable not just of rising into the air, but of making controlled, long-duration flights at high altitudes, in order to systematically record the planet's surface. At first glance, this sounds like a bold assumption. If such technologies existed, why is there no widespread evidence of them? Were they the exclusive property of a small group, the military, or a secret society? Or perhaps the history of technological development wasn't the straight line we imagine, and some breakthrough inventions were made, but then, for some reason, were forgotten or abandoned. This version doesn't rewrite all of human history, but it forces us to admit that the 19th century was far more mysterious and technologically advanced than we are taught to believe. The second theory is even more radical and takes us deep into the mists of time. According to this view, the cartographers of the 19th century were not pioneers, but restorers. This hypothesis suggests that they came into possession of an incredible inheritance, a complete and perfectly accurate map of the world created by a previous, much more advanced civilization. The task of 19th century scholars was not to create a map from scratch, but to adapt it to their contemporary reality. Imagine the colossal undertaking, taking an ancient but perfect template and overlaying it with the modern names of cities, rivers, and countries, and marking the political borders of the time. This explains why the outlines of the continents are so accurate. They were simply copied. This task, though it would have required years of labor and hundreds of specialists, no longer seems impossible. It transforms from a mission of exploring the unknown into a project of cataloging and updating existing data. Furthermore, this version neatly explains the existence of earlier, more primitive maps. They could have been created artificially, by deliberately degrading the accurate map they possessed, in order to construct a logical, sequential history of cartography from Ptolemy to Mercator and beyond. Both of these hypotheses, when you think about them, sound like wild fantasy, like something born of ignorance. One asks us to believe in lost 19th century technologies, the other in the existence of a mythical, ancient super-civilization. But we are cornered by the very existence of these maps. The official explanation for their origin doesn't stand up to scrutiny. Therefore, we have no choice but to step onto the shifting sands of speculation. And before we get lost in theories about unknown civilizations and their legacies, logic dictates we take the first step. Let's try to find evidence that, in the 19th century, it was indeed possible to rise into the sky. Before diving into the depths of hypotheses about ancient legacies, let's act like true investigators. Let's go to the archives and see what official 19th century history itself tells us. Perhaps we are overlooking something important, a detail that is hiding in plain sight. And surprisingly, we don't have to search for long. The answer is found almost immediately, and it is stunning in its simplicity. The ability to rise into the sky existed long before the Wright brothers, and even before the 19th century began. We are talking about aerostats, or hot air balloons. The first documented flight of such a craft with people on board took place in 1783. Just think about that date. It was still the era of powdered wigs and muskets, long before steam locomotives and the telegraph. In France, the Montgolfier brothers lifted a balloon filled with hot air, opening the way to the sky for humanity. It was an event of planetary scale, a miracle that captivated the imagination of the world. For the first time, humans could leave the ground and see the world as only birds had seen it before. And this new perspective changed everything. By ascending to a height of just 150 feet, you can already see the horizon 16 miles away. And if you ascend to 6 miles, which was technically difficult but theoretically possible, the horizon recedes to over 200 miles. Of course, it's impossible to see details at such a distance, but the principle is clear. From a height, you see not isolated fragments, but a complete picture. Forests, rivers, lakes, roads, and settlements come together in a single mosaic, a map drawn by nature itself. The main problem with balloons was their complete dependence on the wind. They were uncontrollable. Wherever the wind blew, the balloon went. But in 1852, the next logical step was taken. Henri Giffard built the first dirigible, a cigar-shaped aerostat equipped with a steam engine and a rudder. It was the first tentative attempt in history to make flight controllable. Of course, those early airships were far from perfect. Their engines were weak, and their structures were cumbersome. They couldn't fight a strong wind and flew slowly, but they could, at least in calm weather, move on a designated course. Now, let's answer the question honestly. Was it possible to create an accurate map of the entire world using these primitive flying machines? The answer is an unequivocal no. To make a transatlantic flight, to systematically fly over and document entire continents, including inaccessible mountain ranges and polar ice caps, was absolutely impossible. There is no point in arguing with that. But is a map of the world always what's needed? Far more often, for practical purposes, maps of a much smaller scale are required. Maps of individual regions, provinces, or counties. And it is here that these imperfect machines become an invaluable tool. Imagine yourself as a 19th century military commander. Your army is facing hills behind which the enemy is positioned. By sending up a balloon, you get a perfect observation post from which you can see the enemy's positions, their fortifications, and their supply routes. This provides a colossal tactical advantage. Now imagine an engineer planning the construction of a railroad, or an economist assessing agricultural lands. By ascending into the air, they could survey an area for dozens of miles around in just a few hours, plot the optimal route, and estimate the scale of forests and fields. For solving such local yet vital tasks, aviation was not just possible, it was extremely effective. So, we have found the first part of the answer. The means to get into the air existed in the 19th century. But a simple view from above is not enough. A cartographer, dangling in the basket of a balloon tossed by gusts of wind, had to somehow record what he saw. Frantically sketching a complex landscape with a pencil, trying to preserve proportions and scale, is a nearly impossible task. To create an accurate map, another equally important element was needed. Another great invention of that era. We left our intrepid aviator in the basket of a balloon, drifting helplessly at the mercy of the wind. A magnificent panorama, the perfect basis for a map, stretches out before his eyes. But in his hands he has only paper and a pencil. He tries to capture the curves of rivers, the outlines of forests, the placement of villages. But his gondola is swaying, the perspective is constantly changing, and small details are lost. The result of his titanic efforts will not be an accurate map, but merely a rough, distorted sketch, full of errors and inaccuracies. The problem of capturing the image seemed as unsolvable as the problem of controlled flight. But at this very same time, in the first half of the 19th century, an invention was being born that was destined to change the world and provide cartographers with the missing link. That invention was photography. The ability to stop a moment in time, to capture reality on a physical medium with documentary precision. The first experiments by Nicéphore Niepce and Louis Daguerre in the 1820s and 1830s were complex and required hours of exposure, but they proved it was possible. By the mid-19th century, the technology had taken a giant leap forward. More light-sensitive materials appeared, and the processes became faster and more accessible. The camera ceased to be a curiosity from an alchemist's lab and became a working tool. A tool capable of doing in a fraction of a second what would have taken an artist hours of painstaking work, creating a perfectly accurate image of the visible world. Now, imagine this device in the hands of our balloonist. The entire picture changes radically. He no longer needs to frantically try to sketch anything. His task becomes technically simple. Ascend to the required height, aim the lens at the area of interest, and take a picture. With one click of the shutter, the complex landscape, with its rivers, ravines, and roads, is permanently captured on a photographic plate. After descending to the ground, in the calm of a study, he could leisurely transfer the contours from the photograph to paper, using projectors or simple tracing paper. It was a revolutionary breakthrough, the union of the two greatest technologies of the era, aviation and photography, gave birth to a primitive but perfectly functional technology of aerial survey. Of course, we shouldn't idealize this process. Early photography was black and white, and this created its own set of difficulties. On a monochrome image taken from a height, it can be extremely difficult to distinguish a small river from an overgrown ravine, or a floodplain from a swamp. Different objects could produce very similar shades of gray. Therefore, aerial photography did not completely eliminate work on the ground. It provided an incredibly accurate foundation, the skeleton of the future map, on which the muscles then had to be built. After obtaining an aerial photograph, a cartographic expedition would go into the field to clarify the details. This process is called interpretation. Specialists would move through the area following a precise plan, confirming details. This is a stream, not a ravine. This is where the farmland begins, and here is the forest. To facilitate this task, there were even special calibrated charts of gray tones that helped to guess what object was on the ground, based on the shade in the image. Thus, fieldwork was transformed from an exhausting exploration of the unknown into a targeted verification and refinement of existing data. So, by the mid-19th century, humanity had a complete set of tools. There were flying machines capable of lifting an observer with a camera to a sufficient height. There were cameras capable of taking an accurate picture from that height. And there was a methodology that combined aerial photography and ground surveys to create maps of unprecedented accuracy. The mystery begins to clear up, and the fantastic theories about lost technologies or the legacy of ancient civilizations seem to give way to a logical and technically sound explanation. We have found a working theory. And so, the fog of mystery that shrouded the origin of old maps seems to be lifting. We have traveled from realizing the impossibility of creating maps from the ground to a logical and coherent theory. We have all the components to solve this historical puzzle. We've established that in the 19th century, balloons and primitive airships already existed, capable of lifting a person into the sky. We know that this was the very era when photography was born and rapidly developed, giving researchers a tool for impeccably accurate documentation of reality. By combining these two elements, we get a working model. Primitive aerial photography, followed by on-the-ground interpretation and clarification of objects. This method explains how it was possible to create maps of local territories with unprecedented accuracy, bypassing both impassable landscapes and hostile borders. It seems the mystery is solved. We can breathe a sigh of relief and close this chapter of history. But it is at this very moment, when the answer seems so clear and obvious, that a new, much deeper and more unsettling doubt is born. Our theory, for all its logic, remains just an assumption, a beautiful intellectual construct. We have only proposed that it was possible. But was the actual technology that we know of truly sufficient to achieve such a result? Were the cumbersome, clumsy hot air balloons and the first imperfect cameras enough to create maps whose accuracy of continental outlines and proportions are comparable to modern ones made with satellites? Let's stop being theorists for a moment and become picky engineers. Let's ask some simple technical questions. What would have been the minimum altitude and stability of the aircraft to get a sharp, clear picture suitable for mapping? Not a blurry mess. What optical characteristics would the camera lens have needed to avoid the geometric distortions at the edges of the frame that would inevitably lead to errors in the map's proportions? What light sensitivity would the photographic plates have needed to get a quality image with the short exposure time required when shooting from a moving object? And the most important question, how was the precise geodetic referencing of these images to the ground carried out, to assemble hundreds of separate photographs into a single, mathematically correct map of an entire region, or even a country? When we start asking these specific technical questions, our neat theory begins to crack at the seams. We assumed it was possible, but we haven't proven it. And now, to confirm or refute our hypothesis, we must search not just for mentions of flights, but for actual artifacts. 19th century aircraft and photographic equipment that would meet these minimum technical requirements. We need to find proof that the technology of the time was capable of this. And this is where things get really interesting. Because when we begin this search, we will indeed find something, but it won't be what we expect. It will be facts and artifacts that fit neither our neat theory nor the official version of history. It will be something that makes the hair on your head stand on end, and that opens the door to a new and far more terrifying mystery.